equation.
So far we've learned a variety of methods to solve quadratic equations. And if you remember the form of a quadratic equation, it is ax squared plus bx plus c equals 0, where a, b, and c are just some numbers, and a is not equal to 0. So some of the methods that we have are factoring, and factoring works in a good variety of instances, but it doesn't always work. Sometimes we can't get exact numbers, or sometimes the numbers are really big and not nice to work with. So what other methods do we have? If you remember, we have the square root method, and that's another method that works in a variety of instances, but it mainly only works when we have an equation of the form ax squared plus c equals 0. We only have that x squared term. So another method that we have is by graphing. And this could be either by hand or by using technology such as Desmos. And the problem with technology is that you won't always have it. Sometimes you'll just have to figure it out on your own. And sometimes graphs by hand can be quite hard to come up with exact answers. So let's talk about a method that will always give us the roots to an equation, and that's called the quadratic formula. So the quadratic formula, based off of our equation here, ax squared plus bx plus c equals 0, we can use these coefficients a, b, and c in this formula here to find the roots. So our roots will be x equals negative b plus or minus square root of b squared minus 4ac over 2a. Another way you could think of negative b this out in front here is by taking the opposite of the b term that is given in your quadratic equation. And so once you've identified your a, b, and c from any given quadratic equation, you can plug those numbers into this formula right here, and it will give you the roots, whether they be nice roots that you could have done by factoring, or roots that aren't as nice and you couldn't have done by factoring. So let's look at an equation here. So let's find the roots of this following equation. We have 6x squared plus 7x minus 5 equals 0. So we have our quadratic formula right here. So all we need to do is figure out what a, b, and c are in order to use this formula. So if we think about a is going to be the term of our x squared. So here our coefficient is 6. B will be the coefficient of our x term. So here it's going to be 7. C is going to be just the constant term in there, the one that doesn't have an x on it. So C is going to be negative 5. Keep in mind that that minus sign will translate over to be a negative 5 over here. So now we can go ahead and use the formula. So we have x equals, we'll take the opposite of b. So if b is 7, the opposite of b will be negative 7. We have our plus or minus. We'll take the square root of b squared will be 7 squared. We have minus 4 because that's in our equation. Now we have our a term, which we found a was 6. And then we'll have our c, which we found to be negative 5. will all be over 2 times our A term. And our A term, as we found earlier, was 6. So now all we have to do is simplify this, and we'll be able to, but this will give us the roots to our quadratic equation. So this then gives us x equals, we can't do anything with the 7 yet, so we'll just have -7 plus or minus. So 7 squared is 7 times 7, which is 49, minus, we have 4 times 6, which is 24, and then 24 times -5 will be -120. And that's all over 2 times 6, or 12. So it's a little cleaned up now. Let's go ahead and figure out what the value under the square root is. So we still can't do anything with this 7, so we still have -7 plus or minus the square root of, when we subtract a negative, we'll add positive, so 49 plus 120, so that will be 169, and then that will all be over 12 still. So, can we simplify under the radical expression? So, in this instance we can, because we know that 13 times 13 is 169. So it's really 13 squared under the square root, which is the same thing as just 13. So we've got x equals -7 plus or minus 13 over 12. And now to find the roots, we'll just expand on this plus or minus term right here. So we can get 2 equations from this, right from our equation here. We can get, using the plus of the plus or minus, we get x equals -7 plus 13 over 12. And then using the minus from our plus or minus, we get x equals -7 minus 13 over 12. So now all we need to do is evaluate those, and that will give us our roots. So -7 plus 13 is going to be the same as 6 over 12, and -7 minus 13 is going to be the same as -20 over 12. So now we simplify these if we can, which in this instance, we know that 6 over 12 is the same thing as 1/2. And we know that -20 over 12 is the same thing as -5/3. So these are the 2 roots of that quadratic equation. X equals 1/2 and x equals -5/3. And if you were able to do this by factoring, you would have found those roots, or by graphing, you would have found those as well. So the quadratic equation was able to just give us a formula in order to solve for those roots. So now let's go ahead and look at this equation right here. 5x squared plus 3x equals 7. So we need to find our a, b, and c in order to use the quadratic formula. But in order to do that, we need it to be in standard form, our ax squared plus bx plus c equals 0. And here we don't have that. What we're going to need to do is we're going to take this 7 and subtract it from both sides to make our equation on the left-hand side equal to 0. So after we do that, we end up with the equation 5x squared plus 3x minus 7 equals 0. And now we can find a, b, and c as we did before. So if we look at our x squared term, we have a equals 5. If we look at our x can just go ahead and plug that into our formula. So we have x equals, we'll take the opposite of b again, -3 plus or minus the square root of, so we'll have b squared, which was 3 squared, minus 4 times, a in this instance is 5, and c is -7, all over 2 times a, which is 5. So if we go ahead and start working to simplify this, we get x is equal to -3 plus or minus the square root of 9 minus 4 times 5 is 20, and 20 times -7 is -140. And that's all over 2 times 5 is 10. So now we'll just go ahead and simplify under the square root again. We know that when we subtract a negative, we add a positive. So then we get that x is equal to -3 plus or minus the square root of 149 over 10. So this time we'll ask ourselves, can we simplify 149 any further? Can we simplify that radical expression? And here we cannot. There's nothing that 149 is divisible by that is a perfect square that we can simplify. So when we split up our equation, we'll just leave the 149 under the square root. So when we expand upon plus or minus again, we'll have x is equal to -3 plus the square root of 149 over 10. And then we'll have x is equal to -3 minus the square root of 149 over 10. And we can't simplify this anymore, so these are the two roots of our equation right here. And this would have been a lot harder to get by factoring, so the quadratic formula definitely helped us get this one here. You could have got it by graphing, but it would have given you a decimal number as well, but you more than likely wouldn't be able to come up with that one on your own. So let's look real quick at one more example here. We have x plus 2 equals -3x squared. So let's go ahead and put this into standard form again. So we add 3x squared to both sides to make the right-hand side equal to 0. That gives us 3x squared plus x plus 2 equals 0. So we have our a term, our x squared, the coefficient is 3. Our b term here, there's a 1 attached to that x, so we can say that b is equal to 1. And then c, our constant term, is just equal to 2. So now we can go ahead and use our quadratic formula again. So we have x equals the opposite of b, so the opposite of 1 is -1 plus or minus the square root of. Here we'll have 1 squared, but it's good to practice writing it with the formula, so I'll go ahead and keep our 1 squared because it's our b squared term. And then we'll have -4 times our a term, which is 3, and times our c term, which is 2. And then that'll be all over 2 times our a term, which is 3. So if we simplify this a little bit, we get that x is equal to -1 plus or minus the square root of 1 squared is just 1 times 1, so that'll be 1 minus 4 times 3 is 12 times 2 is 24 over 2 times 3 is 6. So when we simplify under the square root this time, we have x is equal to negative 1 plus or minus the square root of negative 23 over 6. And here, under the square root, we have a negative number, a negative 23. So what that means is that for this equation, there are no real roots because we cannot take the square root of a negative number. So using the quadratic formula, we're able to solve any quadratic equation once we put it in standard form, and it'll guarantee us an answer, unlike factoring